This is 1.5, subtracting rational numbers. This is the final section, final lesson in chapter 1. And we will be finding the differences of rational numbers. Let's get into it. The key idea is similar to what you did in 1.4. I always think of subtracting numbers is adding the opposite. So you add the opposite. If you look at this example here, it has 1/5 minus a negative 4/5. So add the opposite. So I'm going to change that to a plus, and I'm going to do the opposite there. It becomes positive. So now it's 1/5 plus 4/5. And that's what it says right here. And they have the same denominator. You can add them. You get 5/5, which is the same as 1. Okay? Subtracting is always adding the opposite. Here's a couple examples. And you can look through the examples and use those as you need. But I want to do the try-its. All right, there's 3 of them right here, and we're going to find the difference. So I have a 1/3 minus a negative 1/3. And I see it's subtraction, so what I want to do is I want to, instead of subtract something, I want to add the opposite. Now I have 1/3 plus 1/3. And when I do that, we get 2/3. All right, let's look at the next one. Negative 3 and 1. I wrote that wrong. Negative 3 and 1/3 minus 2/3. So I'm subtracting, and when I subtract, I want to change that to adding. So what I'm going to do is I'm going to add the opposite. So now I have a negative 3 and 1/3 plus negative 2/3. And because it's a negative plus a negative, it's the same sign. It's just going to be a negative in the end. Okay, I'm going to convert this to improper, so that would be 10/3 plus 2/3 equals 12/3. And then I can simplify it, divide each by 3. Gets me 4/1, which is the same as 4. And so my answer to number 2 is -4. Let's do one more. Okay. 4 minus 5 and 1/2. So I'm going to add the opposite. I add opposite. Now there are different signs. I'm adding different signs. I have a positive 4 and a negative 5.5. So I want to figure out the absolute value of this is 4, of this is 5.5. So 5.5 is bigger than 4. So I know in the end, I'm going to have a negative. Once I have the negative, once I know it's negative, then I take the bigger 5 point, I'm going to make that 5.5, and I'm going to take away 4 from it. And that leaves me with 1.5. A negative 1.5. Here's some more examples. You can look through the example 2.4 minus 5.6. But I want to give you the try it examples. And if you want to pause the video and try them and then see how you do, that's good too. But let's do number 4 first. We have negative 2.1 minus 3.9. I'm going to add the opposite. So now I have a negative plus a negative. I know I'm going to get a negative. And when I'm adding two negatives, I just add the absolute values of them to get. So 3.9 plus 2.1, and that gets me 6, negative 6. All right. Let's do negative 8.8 minus negative 8.8. When you subtract, I want you to add the opposites. Add the opposites. So let's add the opposite. Now in this one, they're opposite signs. They're different signs. We have a negative and a positive. And when that's the case, negative and the positive, if they're the same number, it's going to equal 0 every time. All right, the last one. 0.45, so that's a positive, minus a negative 0.05. And I see that it's minus, and I'd rather add, so I add the opposite. And when I do that, I get 0.45 plus, they're both positive, so I just add them, 0.05. When I do that, it gets me 0.50. 0.50, or I could say 0.5, or I could say 1/2. All right? All right, this next section is where you have just more than one thing that you're adding or subtracting. You have 3 different values that you're putting together. So look at this one. We have a negative 2 minus 2/5 plus 1 3/5. So what I do is I take it one problem at a time. So I look at this first one. I have a negative 2 minus a 2/5. It's subtraction, and I'd rather do addition, so I add the opposite. So now I'm adding this negative 2 with this negative 2/5. So that is both the same sign. So because they're the same sign, I just add them, and I'll get a negative. So negative 2, I'm going to make that into a fraction, plus negative 2/5. Now I need the same denominator, so I'm going to make 5 my denominator. And that 2/5 is the same, but this one is going to be 10, negative 10/5 plus negative 2/5. And when I'm adding a negative 10 plus a negative 2, that gets me a negative 12/5. Okay, so then I have to bring down this part right here, plus 1 3/5. I'm going to make that into a improper. 5 times 1 is 5, plus 3 is 8. So I have a negative 12/5 plus 8/5. Now I have different signs. This one is a negative, and this one is a positive. So I got to figure out which one's bigger. And I know that 12/5 is bigger than 8/5. So because 12/5 is bigger than 8/5, the absolute value is at any rate, I'm going to take the sign of this one right here, which is a negative. So it's going to be a negative. Now all I do is I look at the absolute value of this one, and I find the difference of it. And the difference between those two is 4. And my 5 comes over. And so my absolute, or my answer is negative 4/5. Negative 4/5. All right, let's try number 7. Number 7, there's 4 of them. So I'm going to give you a little different method on this one. 7.8 minus 3.3 minus negative 1.2 plus 4.3. Now, I see I have 2 subtraction problems here. I'm going to change those. Add the opposite and add the opposite. So now what I really have here is I have 7.8 plus negative 3.3 plus 1.2 plus 4.3. So what I'm going to do is I'm going to put all my positives together. So I have a 7.8, a 1.2, and a 4.3. And when I do that, 7.8, 1.2, 4.3. That gets me 8, 9, and then 13. Okay, 13.3. So I have 13.3, and then I have to add my negative to it, which is the 3.3. And I see that we have different signs. We have a positive on this side and a negative on this side. Which has a bigger absolute value? That one does, so it's going to be positive. And because they're different, I find the difference. So I take 13.3 minus 3.3, and that is 10. So the difference of those is 10. The bigger absolute value is positive, so I know my answer is going to be a positive 10. Okay? Hope that makes sense. I could have just done this problem first, and then take the answer to that, and add that to it, and then take the answer to that, and add that to it. I could have done that also, and I would have got 10. This next section is finding the difference. The distance, not the difference, the distance between a couple of numbers. And so a number line can help you with this. So the examples I'll give you are with the triads. If I have negative 3 and I want to find the distance from there all the way to a positive 9, I know that it's going to go from here all the way to 0, so that's 3, and then from 0 to 9 is 9. So the distance between those two is 12. Okay. Let's look at number 10. Negative 7.5 and negative 15.3. So in a number line, you have negative 15.3 right there. You have negative 7.5 right there, and you'll eventually have 0 down there. So I just need to go from here to here. So the distance for these two is just going to be the difference. Okay? So I take 15.3 minus 7.5. That gets me, bring down my decimal, 7.8. So from here to here is 7.8. Now it's an actual value distance, so it's always going to be a positive number because that's the distance, 7.8. Now let's do number 11. 1 1/2 and negative 2/3. So the negative 2/3 is right here, 0 is right here, and over here is a positive 1 1/2. So I got to go from here to 0, and then from 0 to there. That'll give me the distance. I know that negative 2/3 to 0 is 2/3, and from 0 to 1/2 is 1 1/2. So I got to add those values together, make this into a mixed. That's 2/3 plus 3/2. Now I need common denominators. I'll come over here. They'll both be 6. So that would be 4/6 plus, let's see, that's times 3, so that's 9/6. And when I do that, it is 13/6. Now I'm going to make that 13/6 back into a mixed number. 6 goes into 13 one time, and then there is 7 left over. So if you ever realize something like that, if I would go with that, then it would be 7/6. And I realize that I still have an improper, which can't be. So it must mean I did the whole number wrong. So let's go back. And I ask myself that same question. 6 goes into 13 2 times. Okay, so that'd be 12, and that leaves 1 left over. 2 and 1/6. 2 and 1/6. So the distance between here, this positive and this negative, is 2 and 1/6. When you have opposite numbers, like a negative and a positive, you have to get the absolute value of both and add them. You have to go to 0 for each one, add them together. There's your distance. For this next section, this is the self-assessment, so I do want you to pause the video. I want you to try 13, 14, and 15 on your paper, and then come back and watch. I'm just going to solve them for you, okay? Let's start with number 13. 4.9 minus 1.6. Add the opposite. I have different signs, a positive and a negative. The positive is bigger, so it's going to be a positive in the end. And because they're different, I need to find the difference. 4.9 minus 1.6, that is 3.3. So 3.3. And I know that the absolute value of the 4.9 is bigger, so it is a positive, and my answer is 3.3. Let's do the next one. 7/8 minus -3/4. It's subtracting. I'd much rather add, so I'm going to add the opposite. And now it's just adding 2 positive numbers. So 7/8 plus 3/4. I just need to have that to have similar denominators. And it is 13/8, which I can say 8 goes into 13 one time. 1, and that leaves me 5, 1 and 5/8. 1 and 5/8. And it's a positive. Okay, and 15. 1/3 minus 2 and 1/6. Instead of subtracting, I'd much rather add. So I'm going to add the opposite. So when I'm adding these, I have a positive and a negative. Absolute value is going to tell me what sign it is. The absolute value of -2.2 and 1/6 is much bigger than 1/3, so it's going to end up being a negative. And because they're different, I need to find the difference. So I'll take the bigger one, 2 and 1/6, and I'll take away the smaller 1/3, make that into an improper, which is going to be 13/6 minus, and I want to make this to have the same denominator, 6, so that's going to be 2/6. So 13 minus 2 is 11/6. And 11/6, 6 goes in there one time, and there's 5 left over, so 1 and 5/6. But remember, way up here, it was negative, so my answer is going to be a -1 and 5/6. Hopefully you were able to get those same answers. Let's do this real-life example. Okay, we have a number line that shows the temperature on each side of the James Webb Telescope when in Earth's orbit. Find and interpret the distance between the points. Okay, so the 2 points. We have a point right here, which is a -388. That's very cold. And then on the other side, we have a 185 positive. So talk about hot. So we have cold and hot. And it says it wants the distance. So we got to take this one all the way to 0, which is a 185. And then I got to take this negative 388 all the way to 0, and that is a 388. And then I add those two values, and it will get me the total distance between the coldest temperature and the warmest temperature. So 8 plus 5 is 13. 8 plus 8 is 16, plus 1 is 17. 3, 1, and 1 is 5. So 573 degrees Fahrenheit is the distance between the points. For the last thing I want you to do is to do this self-assessment, this problem solving on your own. Give it a try. Just attempt it. We have 16 and 17. And one is a dig deeper, which hopefully will push you a little bit more. But think about what you've learned in this video so far and try and apply it in this problem solving problems. All right?